morning, esteemed judges. We are the team from Taiwan Businessman Dongguan School in grade 10. I'm Xin'er Tang.
I'm Chaiyun Lin.
Whether in summer or winter, people are all fascinated by the bubble tea due to its unique texture. But the variety of starches used to make bubbles on the market has significant differences in taste. By studying the molecular of amylose and amylopectin and observing their gelation process, we aim to explore how different starches influencing the elasticity and the toughness and their final taste.
Our research focuses on how the different properties of starches influence bubbles' taste. We took the ratio of amylose to amylopectin and gelatinization characteristics as our entry points. To reach them, we conducted a simplified elasticity experiment and toughness experiment and analyzed the colinear relations between those physical properties. The study found that the above factors do cause bubbles to show different gelation states and retrogradation traits, impacting their overall mouthfeel. Lastly, we carried out a big data statistical survey, which also showed that the bubbles made from cassava starch are the most popular ones.
During our research process, we noticed that people always describe the bubble's texture differently, like soft or springy, but these words weren't scientific. So to make our study reliable, we racked our brains to quantify the whole experiment, turn the chewiness into numbers like elasticity and the toughness values. This way, we could compare the results objectively. After reading a large number of literature and materials, we found that no one has quantified the bubble's texture into elasticity and toughness data. Therefore, we attempt to design a completely innovative experiment to achieve the goal of visualizing the bubble's texture into elasticity and toughness data. Using self-made experimental tools such as vernier caliper, acrylic plates, and petri dishes, we try to analyze the physical properties of bubbles made from various starches.
We continuously press the bubbles made from 4 types of pure starch and 2 types of mixed starch 5 times each. Recorded the data of 3 dimensions, including the rebound time, the average applied force, and the degree of deformation, and visualize them as curved graphs, attempting to explore the reasons behind those changing trends. The elasticity test revealed the following. First, the rebound time reflects the recovery ability of gels. Different curves indicate the internal structure of gels formed by different starches. Gels with good elasticity, moderate stickiness, and stable structure are prone to quickly returning to their original shape. In contrast, bubbles with longer rebound time have lower stickiness and or excessive viscosity, leading to slower recovery. Second, it can be observed from the chart. The average applied force increased with the number of presses. During the compression process, the intermolecular distances gradually decrease, causing the attractive and repulsive force to continuously increase. So greater force was required to overcome the intermolecular interactions. As the number of presses increased, the internal structure of bubbles was gradually damaged, leading to the onset of plastic deformation. Additionally, each press expelled more air from the inside of the bubble, causing the structure to being more compact and leaving less space for particle movements.
Third, the chart shows the deformation curves of bubbles made from different starches follow a similar trend. The glutinous rice starch is almost entirely composed of amylopectin, whose molecular chains can easily slide and shift under the external pressure. On the contrary, the cornstarch contains higher proportion of amylose, where the molecular chains are bound together by hydrogen bonds or other forces, forming a tight and orderly structure.
In toughness test, the bubbles made from glutinous rice starch were excessively sticky and didn't break under the same application of force, but it also didn't break. The bubbles made from sweet potato starch and corn starch have lower stickiness and less stable structure, which leads to the breaking under the application of force. The bubbles made from cassava starch and other two types of mixed starch still exhibited rebound, with those made from cassava starch demonstrating the best rebound performance.
There are some key factors influencing the bubble's properties. First, from the above chart, we can observe the ratio of amylose to amylopectin. Amylose shows a linear structure, while amylopectin shows a branch tree structure, which definitely influencing the entry of water molecule and their final taste. Second, gelatinization temperature is also one of the factors. Cassava starch exhibits stronger gelation, forming an elastic and chewy texture. The cornstarch requires high temperature and longer gelation time, leading to a strong gels. And the sweet potato starch forms strong yet less elastic structure, leading to a dense and fibrous texture. But the glutinous rice starch gels at low temperature into soft, sticky, and elastic texture. Finally, we conducted a questionnaire survey, which is also a part in our quantitative experiment. The result shows that 80% of the respondents believe that the cassava bubble could score 4 or more points out of 5, which confirms that the cassava bubble do have the best taste.
Generally speaking, this experiment aimed to explore the factors affecting the bubble's texture and properties. The results show some discrepancies with our initial hypothesis. While the amylose to amylopectin ratio is indeed one of the factors affecting bubble's taste, it is not the determinant one. During the gelatinization process, aside from the impact of linear and branched chain structure, the intrinsic gelatinization characteristics of starches significantly influence the network structure. This structure affects the connection points during gelatinization and leads to differences in elasticity and toughness, which ultimately impact the taste of the bubbles. In summary, there are multiple factors affecting bubbles' texture and properties. So in practical applications, it is essential for us to consider comprehensively to achieve our desired outcome.
In the future, we recommend investigating the effects of added edible agents or adjusting nutritional components on starch gelatinization and the texture of bubbles. Applying such techniques to food processing could further enhance the product quality and improve the consumer's experience. Thank you for listening.